We are going to estimate the elliptical quadrant y bar, but using horizontal strip. We have the drawing of the quadrant, elliptical quadrant, with A major x on the x-axis and B is the vertical minor x at the y-axis. If we use horizontal strip, the length will be x and the height will be dy. Apart from the x-axis by distance y, we are going to integrate that strip from y equal to 0 to y equal to b. Our x, by using parametric equation, is a cosine theta, while the y will be b sin theta. Then we can get the value of dy by differentiating y with respect to theta, which will give us b cosine theta d theta. Our normal expression, the integration of dA multiplied by y, will be equal to x dy multiplied by y. We are going to substitute the values for x and y and dy. So the integration from 0 to pi over 2, for x we are going to put a cosine theta, and for the dy we have b cosine theta d theta, and while for the last term, which is y, we have b sin theta. We have common a by b, we have b squared a, we get it out, and we have cosine theta by sin theta, we get 1 cosine theta out, so we left with sin theta cosine theta d theta. We will multiply it by 2 and divide by 2 to convert it to the expression of sin 2 theta. So ay bar equal to ab squared integration from 0 to pi over 2 of cosine theta over 2 by 2 sin theta cosine theta. For the 2 sin theta cosine theta, it's equal to sin 2 theta. So our term ay bar equal to ab squared over 2 multiplied by the integration from 0 to pi over 2 of cosine beta multiplied by sin 2 theta d theta. We are going to use alpha and beta expression. We are going to consider that alpha equal to 2 theta and beta equal to theta, and we have a rule that if we have sin alpha by cosine beta, it can be set equal to 1/2 sin alpha plus beta plus sin alpha minus beta. So ay bar equal to ab squared integration from 0 to pi over 2 multiplied by 1/2. Our sin alpha plus beta will be sin open bracket 2 theta plus theta, which is sin 3 theta, plus the sin alpha minus beta will be sin 2 theta minus theta, which is tan theta d theta. We get 1/2 multiplied by 1/2 out, so we have ab squared divided by 4 multiplied by the integration of sin 3 theta d theta is minus cosine 3 theta divided by 3 from 0 to pi over 2, while the integration of sin theta d theta from 0 to pi over 2 will be equal to minus cosine theta. So ay bar equal to ab squared over 4. We are going to substitute minus cosine 3 pi over 2, which is 0, divided by 3 minus another term, which is cosine 0 will be set to 1 multiplied by minus, so we have plus 1 over 3 minus the cosine theta. Cosine pi over 2 is 0, again minus cosine 0 is minus 1. At the end we have ab squared over 4 open bracket, we have 1/3 plus 1, which is 4 over 3 multiplied by ab squared over 4. Then we will get the expression of y bar for will go with 4, and we left with AB squared over 3. From the previous information, we have AY bar equal to AB squared over 3, while previously we have proved that A equal to by AB over 4. So Y bar will be set equal to AY bar over A, which means that we are going to divide AB squared over 3 over by AB over 4. 4 will come up, so we have 4 over 3 AB squared divided by AB. 1b goes with 1 of the b squared, so we have at the end 4b over 3 by. In the sketch we have for the elliptic quadrant, the CG is apart from the y-axis by distance equal to 4a over 3 by, while the vertical distance y bar equal to 4b over 3 by, which we have just proved, for the major x distance equal to a and the minor x distance equal to b. Thanks a lot, and see you in the next topic. Goodbye.